Scientists have just discovered that the Andromeda galaxy is twice as big as we ever imagined. So huge, its outer edge is already touching our own Milky Way. That means our galaxy isn't alone anymore. For centuries, we believed Andromeda was a distant neighbor, calm, silent, drifting far across the cosmic ocean. But in reality, it's already reaching for us. Every second, it moves closer, 400,000 kilometers per hour, dragging billions of stars toward a future collision that will reshape the night sky forever. This is the story of Andromeda, the silent giant we thought we knew, until now. Long before telescopes, long before we even knew what galaxies were, ancient sky watchers noticed something strange high above the horizon, a tiny, blurry patch of light. It didn't shine like a star, and it didn't move like a planet. It was just there, silent, mysterious. For centuries, people could only wonder what it was. The first written record of Andromeda comes from a Persian astronomer named Abd al-Rahman al-Sufi, around the year 964. In his famous book, The Book of Fixed Stars, he described it as a small cloud floating in the constellation Andromeda. Imagine that. Over 1,000 years ago, someone looked up at the same spot in the sky and noticed the faint glow of an entire galaxy, without having any idea what it truly was. Centuries later, when telescopes were invented, astronomers finally got a clearer look. By the 1600s, observers like Simon Marius and later Charles Messier saw Andromeda through their primitive telescopes. It looked like a hazy oval, and they called it a nebula, which means cloud in Latin. Back then, no one knew that galaxies beyond the Milky Way even existed. Everyone believed the universe was just our galaxy, surrounded by stars. That belief continued for hundreds of years, until one man changed everything. In the early 1920s, American astronomer Edwin Hubble turned the world's most powerful telescope toward Andromeda. What he saw inside that blurry patch shocked the scientific world. Using variable stars called Cepheids, he measured its distance and found that it was over 2 million light-years away. That meant one thing. Andromeda wasn't part of our Milky Way at all. It was a completely separate galaxy, another island of stars floating in the endless ocean of space. Hubble's discovery shattered our understanding of the universe. Suddenly, the night sky wasn't just filled with stars, it was filled with galaxies, each holding billions of suns. Andromeda became the first proof that our Milky Way is just one of countless galaxies out there. What began as a faint blur noticed by an ancient astronomer turned out to be our closest galactic neighbor, and the beginning of a new chapter in human knowledge about the universe. For most of modern history, scientists believed Andromeda was a little larger than the Milky Way. Big, yes, but not extraordinary. The truth is, we were only seeing a fraction of what it really is. The reason? Most of Andromeda is invisible. When astronomers first measured Andromeda's size, they could only rely on visible light, what telescopes could actually see. That meant the bright central bulge, the spiral arms, and a faint halo of stars around it. Everything beyond that appeared empty, black, and silent. So, for decades, scientists assumed that was where Andromeda ended. But the universe hides its biggest secrets in the darkness. In the early 2000s, more advanced telescopes began revealing something strange. When researchers looked beyond the visible parts of the galaxy using X-ray and ultraviolet imaging, they started to notice a huge, faint glow surrounding Andromeda, far larger than anyone expected. It wasn't made of stars, but of hot gas and dark matter. This invisible halo extended hundreds of thousands of light years in every direction. To understand just how massive that is, imagine a galaxy so wide that if our Milky Way sat inside it, we would barely reach halfway across. That's how big Andromeda truly is. The reason scientists missed it for so long is because this halo doesn't emit visible light. It's incredibly thin and transparent, detectable only through special instruments that can read faint X-ray signals. Without this technology, Andromeda's true scale was hidden from us, like seeing only the tip of an iceberg and not realizing there's a mountain of ice below the surface. When researchers finally mapped this invisible region, they realized Andromeda's halo was as massive as its main galaxy, possibly even more. This discovery doubled Andromeda's estimated size and revealed that it's easily one of the largest galaxies in our local group, maybe even larger than the Milky Way itself. For decades, we looked at Andromeda and thought we understood it, but what we were really seeing was only its bright, visible heart, not the enormous cosmic structure that surrounds it. And that realization changed how astronomers measure every other galaxy in the universe. The real turning point came when NASA's Hubble Space Telescope and later the Chandra X-ray Observatory joined forces to study Andromeda in greater detail than ever before. For years, scientists had known Andromeda was big, but they didn't know where it actually ended. Was it 200,000 light-years wide, 500,000, or more? The problem was, its outer edges were invisible to traditional telescopes. So astronomers turned to a new kind of observation, one that didn't rely on visible light at all. Using ultraviolet and X-ray imaging, they began searching for signs of ionized gas, the faint, glowing fingerprints of matter that surround galaxies. The data came slowly, collected from years of observation and deep space scans. And then, the picture started to emerge. What they found was astonishing. Andromeda's halo, the invisible atmosphere of hot gas and dark matter surrounding the galaxy, wasn't just large, it was colossal. According to the data, the halo stretched nearly 2 million light-years from one side to the other, reaching almost halfway to the Milky Way. That meant the outer layers of Andromeda were already interacting with our own galaxy's halo, billions of years before their actual collision. This discovery was one of the biggest breakthroughs in modern astronomy. The findings came from a massive research project called Project Omega, absorption map of ionized gas in Andromeda. Scientists studied how light from distant quasars, bright galaxies far behind Andromeda, changed as it passed through Andromeda's invisible gas. By measuring those subtle changes, they could trace the shape and thickness of the galaxy's halo, like using shadows to map an unseen mountain. The results revealed that Andromeda's influence extends much farther than anyone expected, possibly covering 10 times more space than the visible galaxy itself. What looked like a small spiral of stars turned out to be the heart of an enormous cosmic system, spreading across millions of light-years. In simple words, this meant that our nearest neighbor is not just another galaxy. It's a cosmic empire with invisible borders that almost touch our own. And for the first time, we could finally define the true boundaries of Andromeda. Boundaries not made of stars or planets, but of energy, gas, and the mysterious force of dark matter. For decades, astronomers believed that the Milky Way and Andromeda were roughly the same size, twin spirals drifting through the same cosmic neighborhood. But as technology improved and the truth unfolded, it became clear that Andromeda might actually be the dominant galaxy in our local group. Larger, heavier, and far more complex than we once thought. At first glance, both galaxies look similar. Each has a bright central bulge surrounded by magnificent spiral arms, filled with billions of stars, planets, and nebulae. Both are about 100,000 light-years across when measured by visible stars. But when you include Andromeda's massive dark matter halo, its full span stretches to almost 2 million light-years, dwarfing the Milky Way. It's not just wider, it's also estimated to be 30% more massive. Andromeda also hosts an incredible trillion stars, compared to the Milky Way's estimated 200 to 400 billion. That means Andromeda contains nearly 3 times as many suns as our entire galaxy. Many of those stars are older, forming soon after the Big Bang, making Andromeda an ancient structure that has survived countless cosmic collisions. Its structure also tells a story of violence and growth. Astronomers have found evidence that Andromeda has absorbed several smaller galaxies over billions of years. These galactic mergers created massive star streams, long trails of stars stretching far beyond the visible disk. The Milky Way has a similar past, but Andromeda's history of cannibalizing smaller galaxies seems even more intense, giving it a bulkier, more luminous appearance. Another key difference lies in the heart of each galaxy. Both have supermassive black holes at their centers, but Andromeda's central black hole is believed to be heavier, around 100 million times the mass of our Sun, compared to the Milky Way's 4 million. This powerful engine fuels radiation, gravitational waves, and dynamic star motion around its core. Yet, despite Andromeda's size and power, the two galaxies share many similarities: spiral arms full of new stars, clouds of interstellar dust, and planetary systems that might even host life. They are like cosmic siblings, born in the same era, evolving separately but destined to meet. And when they finally collide billions of years from now, their differences in size, mass, and structure will decide the shape of the new galaxy that emerges from their union. What truly makes Andromeda extraordinary isn't just the stars we can see, it's the vast, invisible world that we can't. Surrounding the galaxy like a ghostly shell is an enormous halo of dark matter, a mysterious substance that neither emits nor reflects light. It's completely invisible, yet it shapes everything, from how galaxies spin to how the universe itself is built. For years, astronomers couldn't understand why Andromeda's outer stars moved so fast. According to physics, they should have been flung out into space, unable to stay in orbit. But they didn't. Something powerful was holding them together, something we couldn't see. That something is dark matter, which makes up nearly 90% of Andromeda's total mass. This invisible halo extends far beyond the galaxy's visible edge, forming a vast, spherical bubble that stretches nearly 2 million light-years across. To put that in perspective, Andromeda's dark matter halo is so large it's already overlapping with the Milky Way's halo, meaning the two galaxies are slowly blending together, long before their visible stars collide. Dark matter can't be observed directly, but scientists detect it through its gravitational effects. When light from distant galaxies passes near Andromeda, it bends slightly, a phenomenon called gravitational lensing. By measuring these distortions, astronomers can map the unseen structure of the halo, like tracing the outline of a creature hidden in fog. What's fascinating is how calm and stable this invisible halo appears to be. It acts as a cosmic skeleton, holding Andromeda's stars, planets, and gas clouds in place. Without it, the galaxy would simply fly apart. And this halo isn't empty. It's filled with hot, ionized gas, cosmic rays, and the faint echoes of past galactic mergers. Every faint particle drifting through that halo tells a story of collisions, growth, and survival. Even today, scientists still don't know what dark matter actually is. It doesn't behave like normal matter, and it doesn't fit into any known theory of physics. But one thing is certain: without it, galaxies like Andromeda could not exist. In many ways, Andromeda's dark matter halo is a reminder that the most important parts of our universe are often the ones we can't see. Silent forces shaping everything around us, from the motion of stars to the fate of entire galaxies. It sounds like something out of science fiction: two massive galaxies, each filled with hundreds of billions of stars, slowly drifting toward each other through the darkness of space. But this isn't fiction. It's real, and it's already happening. Right now, Andromeda is moving toward the Milky Way at a speed of about 110 kilometers per second. That's roughly 400,000 kilometers per hour. Even at that speed, the journey is incredibly slow on a cosmic scale. The collision won't happen tomorrow, or even in our lifetime. It's expected to begin around 4 billion years from now. When it does, the result will be breathtaking. As Andromeda and the Milky Way draw closer, Their halos, those massive, invisible clouds of dark matter and gas, will collide first, blending together long before their stars ever meet. Then, over millions of years, their spiral arms will begin to stretch, twist, and tear apart under immense gravitational forces. But here's the fascinating part. Despite how dramatic it sounds, very few stars will actually collide. Space inside galaxies is mostly empty. Instead of crashing into each other, the stars will pass by like silent ships in an endless ocean. Yet their gravity will reshape everything. Some stars will be thrown out into deep space, while others will be pulled toward a new center. At the heart of this chaos, the two supermassive black holes, one from each galaxy, will spiral toward each other and eventually merge, forming an even larger black hole, millions of times heavier than the Sun. Around this monster, a new galaxy will form, no longer the Milky Way, no longer Andromeda, but a completely new cosmic structure scientists already call Milkomeda. For Earth, the view will be spectacular. If humanity, or whatever life exists then, still looks up at the night sky, they'll see Andromeda growing larger each night, transforming from a faint blur to a glowing spiral dominating the heavens. Over millions of years, the sky will be filled with streams of stars as two galaxies become one. In the end, the Milky Way and Andromeda's collision won't be the end of beauty. It'll be the beginning of something even grander, a new galaxy born from the union of two cosmic giants. The discovery of Andromeda's true size doesn't just tell us about one galaxy. It changes how we understand the entire universe. For generations, humans have tried to measure the cosmos, to put numbers on distances so vast our minds can barely imagine them. But every time we think we've reached the edge, the universe finds a way to show us it's even bigger than we believed. When astronomers realized that Andromeda's halo stretches nearly 2 million light-years, it forced them to rethink how galaxies interact and where their boundaries truly end. It showed that galaxies aren't isolated islands in space. They are connected, their halos overlapping, influencing each other through gravity, radiation, and dark matter. This means the universe is not a collection of separated systems. It's a vast, woven web where everything is linked in ways we're only beginning to understand. This discovery also helps scientists estimate how much dark matter and energy fill the cosmos. Because if Andromeda's invisible halo is this huge, then other galaxies likely have similar halos too, some even larger. Multiply that by the hundreds of billions of galaxies across the observable universe, and you begin to realize that what we can see, the stars, the planets, the glowing nebulae, makes up less than 5% of reality. The rest lies in the unseen forces that shape everything. Andromeda's massive scale also reminds us of how small we truly are. Our Milky Way, with all its stars and worlds, is just one of countless galaxies floating in an ocean of space that stretches 93 billion light-years across. The more we learn, the more humbling it becomes. Every discovery pushes the boundaries of what we thought possible. But perhaps the most beautiful message hidden in Andromeda's enormity is this: the universe is still full of mystery. Every telescope, every satellite, every new discovery brings us closer to understanding it, yet at the same time, opens 1,000 new questions. So when you look up at that faint blur of light in the night sky, remember, you're not just seeing another galaxy. You're looking at a mirror of our own, a silent reminder that we are part of something unimaginably vast, ancient, and endlessly expanding.